Hello, welcome to the Ansys video tutorials, and in this video tutorial we are going to see two-dimensional heat conduction problem inside the Ansys workbench. So let me first select steady state thermal analysis system. You can see over here this is steady state thermal analysis system. The steady state means basically it is independent of time, and thermal analysis system, so we are going to first select that, and we are going to give the material for this heat conduction as a user defined material with thermal conductivity of 1 watt per meter second. And then you can just go to the geometry and you can click on the geometry, and inside the property of geometries you can set the analysis type as a 2D analysis type. You can go to the engineering data, select edit option, and inside engineering data you can click here to add a material, and you can give the material as material 1. You can go to the thermal and add isotropic thermal conductivity to the material 1, and you can enter the value of 1, and then you can exit from this engineering data, and then you can again click on the geometry and you can say new design modeler geometry, and the design modeler will now open into the new window. Now you can see that design modeler has been opened. Now we can select XY plane and start sketching on this plane and go normal to this plane. We can go to the sketching tools, select rectangle, and from this to this you can draw a rectangle. You can go to the dimensions and select this dimension as, and again select this dimension. So you can select the horizontal dimension as 1 mm and vertical dimension as 2 mm. So you can see I have generated this sketch 1 meter. Sorry, this is in meter. So you can go to the units and you can see by default our unit is meter. So this is 1 meter and this is 2 meter. Now you can say generate and you can go to the modeling tools. You can go to the concept and you can select surface from sketches. You can already this sketch has been selected, so you can say apply, and thickness is 0 meter, so you can say generate. You can see that we have generated this surface. Now you can hide these sketches. Also you can hide this axis. In this way we have created a geometry. Now you can go to the file and you can close design modeler. Then you can go to the Ansys workbench and here you can click on this and edit. Now you can see that Ansys mechanical now will open into the new window. Now you can see that Ansys mechanical has now been opened, and you can see that the surface where x-axis dimension is 1 mm 1 meter and y-axis dimension is 2 meter. And now we can again go normal to this and you can see the materials, and you can go to the geometry first of all, and inside this you can see surface body. You can go here and you can select a material assignment as a material 1 in which thermal conductivity was 1, and now you can again go close this geometry option. Then again you can go to the materials and you can see the properties. If you want, you can select a mesh and you will say update. So you can see that mesh has been generated, and inside this you can go to the statistics and you can see number of nodes and number of elements. So there are 66 total elements and 233 nodes. Suppose I want to edit this mesh, so you can go and right click on the mesh, you can say insert, and then you can say face meshing. Then you will select this face. So when you select this face, you can say apply, and then you can just say generate. So now face meshing will be generated. and you can see in earlier mesh these lines were not exactly vertical. Either it may be problem of the graphics, or now you can see that these lines are completely vertical and you can see good kind of mesh. And again you can go to the face meshing or mesh, and you can see number of nodes and elements are again same. Now we can also add the sizing to this mesh. So go to the mesh, right click, and you can see insert, and you can see sizing option, and you can see the geometry is this geometry. So you can say apply, and element size you want to specify. You can also specify the sphere of influence and factor of global size, but I will select the element size, and I will select the element size as 0.125, and I will say generate. Now it will generate a mesh, and this is quite a fine mesh. And so now we'll again go inside the steady state thermal. When I select steady state thermal, you can see the environment changes, and you can see thermal options over here. Now you can specify the different boundary conditions. Now inside Ansys, you should know that there are two types of boundary condition, that is natural boundary condition and essential boundary condition. Now you must know the difference between natural and essential boundary condition. So let's first try to provide boundary condition. Suppose if you want to specify the temperature and at this edge, okay, so as it is a surface and it is a 2D heat conduction problem, so we can specify the surface at this edge, or we can specify the temperature at this edge. So we'll select the edge selection, and then you can select this edge. We'll say apply, and here you can specify the temperature of 0 degree Celsius. Okay, and again you can go to the steady state thermal, and again you can set a convection boundary condition at this edge. Again you can say apply, and film coefficient say 5 watt per meter square degree Celsius. And then again you can see the another properties, but now we can see that we have applied temperature boundary condition over here and convection boundary condition over here. What about these two edges? So when you don't apply any boundary condition at these two edges, automatically there will be no heat flux or no heat flow through these edges. Okay, and we'll also this confirm this by your results. Okay, so now we can see that there are two boundary conditions, that is temperature, which is A, which is 0 degree Celsius, and convection, that is 22 degree Celsius, and we have convection coefficient, that is 5 watt per meter square degree Celsius. Again you can say, now you can say Ansys to solve the problem. Now you can see the Ansys solution status. It will take some time and it will generate a solution. Now you can see that solution has been generated. Now you can do post processing. Now inside a solution you can add a thermal solution, that is temperature. So you can set temperature. Also if you want to find total heat flux, you can add that. And now if I want to evaluate all the solution, you can just right click on the solution and say evaluate all the results. And now you can see the results have been evaluated. You can find the solution information inside this worksheet. So it will take very large time to read all the solution. So we are directly shifting towards color plots. Now you can see how the temperature varies inside this 2D surface, and maximum temperature is 20 degrees Celsius, minimum is 0 degrees Celsius, which is at this edge, which was our boundary condition, and here it was a convection. And you can see this by means of counters. You can see smooth counters. You can also see the ISO lines. Okay, ISO lines separates the different temperature lines, and you can also see solid fill. So we'll see smooth counters, and you can see that how the temperature distribution occurs over here. You can run the animation, and you can see how the temperature variation occurs inside this 2D surface. Now again you can go to the total heat flux, and you can see how the heat flux occurs inside the surface. You can see its variation. Also if you select vectors, uniform, grid align, okay, and solid form vectors, you can see how the heat will be flowing, and you can see direction of heat flux. Now, as I specified, these two edges are basically, we have not specified any boundary condition at these two edges, so no heat flux will occur through these edges, okay. And you can observe that we have specified the temperature boundary condition at these edges, okay, and convection boundary condition at these edges. So you can see heat flux occurs in this direction, okay, heat flux occurs in this direction where the temperature is lower, and in this way we can analyze the results. As you can see over here, that inside our convection boundary condition, you can see the ambient temperature, that is 22 degrees Celsius, means this edge there is a convection boundary condition where the heat transfer coefficient is 5 watt per meter square per degree Celsius, and over here just at right side of this edge you can see the ambient temperature, that is 22 degrees Celsius, okay. And you can see that, and over here you can see 0 degrees Celsius temperature. So heat will basically enter from this 22 degrees Celsius inside the surface, and it will flow in this direction, and that is what is shown by the software, okay. And in this way you can see the direction of this heat flux. You can see the maximum heat flux occurs at this corner, and in this way you can analyze the results. Also temperature distribution, you can see the temperature distribution, and you can see the different counters for the temperature distribution. So let's create a path to analyze the results. So you can go to the model, and inside the model you can go to the construction geometry and select a path, and now you can select different points, and you can analyze the results across those points. Suppose I want to find temperature along this line, okay, along this line. So I will first select the point. So for this you can go and selection vertex, and you can select this, but you are not able to select, so we have to specify then coordinates. So x coordinate is 0 and y coordinate is 1, and again the end is x coordinate is 1 and y coordinate is also 1, and you can see this is my path, and this path you can rename as y equal to 1. And then you can go to the solution. Again you can select a thermal, and you can select a temperature, and here you can select inside geometry selection, you can select a path, and inside a path you can select a y equal to 1, and you can say evaluate all these results, and you can see the temperature distribution along this line. Now when you select a path, you can see there are 47 points. So, and when you go to the temperature, here you can see tabular data, and inside tabular data you can see 49 points. So there will be 49 elements, and first and last 2 points that will form the 2 extra elements, that is 49 points it will be, and you can see the temperature values at along this line. And here you can also see the graphical data, and you can also create animation for this. So in this way we can work with the Ansys. Now here if I again want to find the heat flux at this path, so or this path or this path, suppose let's select heat flux at this path, and for that you will have to create again a path. So you can go select path, you can select the point. Suppose at this we want to find it, so we'll select 0, x equal to 0, y equal to, so we have y equal to, we can say y equal to is equal to 0, that is its origin over here, and you can say again x equal to 1 and y equal to 0. So you can see this is the line, and we can again go to the solution, and inside solution you can insert a thermal temperature, and inside temperature you can select a path, and inside a path you can select path option, and you can say evaluate all the results, and you can find the temperature along this line. Okay, and you can see the temperature is almost 0 along this line because we have specified the boundary condition, so it will always remain constant. Again, if you want to insert thermal total heat flux, and here geometry selection, again we will select a path, and inside a path we can select a path, so that is this path, basically line joining this point, 2 points. We'll say evaluate all the results, and you can see the heat flux through this edge, and you can see the graphical representation of the heat flux as well as tabular representation of this data. So you can just go closer and you can see these results. So at this edge you can see highest heat flux, and over here you can see least heat flux, because this boundary condition here it was interacting with ambient temperature, which is 22 degrees Celsius, and maximum and minimum value you can see in this graph. You can also add the additional points. In this way we can work with the results, and we'll see another option, like we can insert a probe, and this probe will be a reaction, and reaction means basically what is amount of heat that is crossing the boundaries. So you can see select a boundary condition, and here we have two boundary conditions, that is temperature and convection. As we already know, inside a problem we have specified the temperature at this edge and we have specified the convection boundary condition at this edge. So let's select a temperature boundary condition. Okay, and at this you can say a reaction probe and evaluate all the results, and in this way you can see that how much amount of heat that is. Actually you can see heat is minus 36.316, means heat is leaving this surface, okay, leaving this edge. And again we'll go to the solution, and we can select a probe and a reaction probe, and we can select boundary condition as convection boundary condition. Again we'll say evaluate all the results, and then you can see that heat is actually positive 36.316, and you can see it means that heat is basically going to enter this surface, that is plus 36. Okay, so from the atmosphere or from the ambient temperature, heat is going to enter and going to leave from here, and no heat leaves from here. As you can see, it means that these two edges are perfectly insulated, and whenever we don't specify any boundary conditions, or when we don't specify the any heat transfer parameter at particular edges, then those surfaces will not create a heat transfer, and we have specified that earlier. And now you can see the proof of this statement, and you can see that same heat enters through this surface and exactly same amount of heat will go from this surface. So in this way we can see the energy balance, that is energy conservation. Okay, so in this way we can work with Ansys, and one more parameter that we can use is we can use probes to determine the temperature at different points inside the temperature distribution. So this shows us the temperature inside the temperature distribution. Also we can see the maximum and minimum temperature, which is at these edges respectively. So here minimum is 0 and maximum is 21. You can also see in this chart. So in this way we can work with Ansys, and we can see the results now. And here you can see the tabular data, here you can see graphical data for each of the quantity, and you can see maximum, minimum and average values. We can see the temperature data as both tabular and graphical. You can see heat flux data, and same way we can find any data. Now if you want to find the solution report, then you can go and you can see the worksheet, that is result summary, and you can also find the result summary. That is, this is not basically a project report, but this is a result summary. So that summary you can see available solution and quantities, and you can find the material and element type information, solver component names, and you can also find the result summary. So all the result, temperature, total heat flux, temperature 2, temperature 3, total heat flux, that we can analyze through this. Okay, so that's all. Now if you want to generate a report, you can click on the solution, and inside solution you can see over here the report preview. When you select report preview, Ansys will generate a report, and it will take some time depending upon the type of solution. And you can see we have generated report. Inside this report you can see the contents, units and model, geometry, construction geometry, material, coordinate system. We can see the mesh preview. Also you can see the steady state thermal inputs, and also you can see the results. So you can see the various graphs also over here. You can see we have generated different graphs for different solutions that we have analyzed, and we can also see tabular data. So in this way we can work with Ansys and generate this report. We can also print this report, as you can see. We can also send this report directly from here, and we can also publish. Also we can control the font size inside this report. Okay, so in this way we can work with Ansys Workbench, and in this video tutorial we have actually analyzed the 2D heat conduction problem inside the Ansys Workbench. That's all in this video tutorial. Thank you. In our upcoming video tutorials we are going to see another tutorials on the Ansys Workbench. That's all. Thank you. Don't forget to like, share and subscribe the channel.